Convert all of the following into proper MKS units. MKS, as we remember, means meters, kilograms, and seconds, and in fact every unit in every quantity known in nature can be expressed as a combination of a length, a mass, and a time. The key when converting units is to leave a quantity unchanged. And what we know is that if you wish to leave a quantity unchanged, I'll write Q to represent some quantity, there is only one number you can multiply Q by in order to leave the quantity unchanged, and that number is 1. What we do when converting units is we find convenient ways to represent 1 such that the resulting manipulations yield the quantity in the units we desire. So for example, since we know that there are 100 centimeters in a meter, 1 can be defined either as 100 centimeters divided by 1 meter, or 1 can be defined as 1 meter divided by 100 centimeters. As we understand each unit conversion in terms of where we begin and where we wish to go, we'll be able to select the appropriate forms of 1 such that we get the desired result. Let's begin. Starting with 2,500 feet per hour, we recognize that this expression has two problems with its units. The feet should be meters and the hours should be seconds. So we begin with the feet. The feet is in English units, and to convert to metric, the number that I remember most conveniently is that 1 inch is equal to 2.54 centimeters. So for that reason, I'm going to attempt to go from feet to inches, inches to centimeters, and then finally centimeters to meters. And that will take care of the feet unit. We still have an hour to go. So to convert feet to inches, I need to select the appropriate form, whether I select a certain number of feet per inch or inches per feet. In order to cancel the feet unit and leave it out of the equation, I wish for that unit to be in the denominator, meaning the inch unit should be in the numerator, and now all I have to do is decide whether it's 12 inches is equal to 1 foot or 12 feet is equal to 1 inch. As I remember it, it's 12 inches is equal to 1 foot. As a result, the feet units will cancel, and I have determined that I need to multiply by 12 in order to get the result into inches. Inches are not good enough. I need to go to centimeters. So in choosing between centimeter per inch and inch per centimeter, I select centimeter per inch because that will cancel the inch units. And I decide that in order to make this 1, I need the numerator and denominator to be equal, and 1 inch is the same length as 2.54 centimeter. I've made it to centimeters. All I need to do now is get to meters, and I'll have finished with the unit in the numerator. Choosing between meter per centimeter and centimeter per meter, the one that will take me where I want to go will be meter per centimeter. And what I remember in order to form 1 is that 1 meter is the same amount as 100 centimeters, indicating that to account for the unit of feet, I will need to multiply by 12, multiply again by 2.54, and divide that result by 100. This will leave the result in meters per hour. That's not quite good enough. We need to keep going, and so we need 1 in yet another form. We could do this in 1 or 2 steps. We could convert hours to minutes, and then minutes to seconds, or we can attempt to convert directly from hours to seconds, which will be 60 times 60, which is a factor of 3,600. I think that's what I'll choose to do. And then I need to decide whether this should be hours per second or seconds per hour. Clearly, in order to cancel the unit of hours, I'd like to have hours in the numerator, seconds in the denominator, and then all I have to do is decide whether there are 3,600 hours in each second or whether there are 3,600 seconds in each hour. And so the result is that the unit conversion tells me to multiply by 12, multiply by 2.54, divide by 100, divide by 3,600, and then I have the final result, 0.212 meter per second. Part B of this problem asks us to convert 3 miles into an appropriate distance in MKS units, and that would be in meters. Even though you might think that kilometers is an appropriate conversion, we wish to make things in MKS units, which means that we'll use meters. So in order to do this, we're going to need to remember how to convert miles eventually into inches. And the first step is to get it into feet, feet to inches, inches to centimeter, and centimeter to meter. It's a little bit difficult to remember exactly how many feet are in a mile because it's not a round unit. You may wonder historically how that ever came about. The answer is that when the English inherited the distance of mile from the Romans, they decided to make it consistent with English units by making it an even number of furlongs, which were their preferred unit for long distances. So, since the 5,000-foot mile from the Romans didn't work out to be an even number of furlongs, they chose to make 8 furlongs equal to 1 mile, which resulted in 5,280 feet per mile. So our job is to decide whether we want to multiply by 1 in the form of feet per mile or miles per foot. Well, since we're trying to eliminate the unit miles, we'd like it to be in the denominator, putting feet in the numerator. And what we've decided is that there are 5,280 feet in 1 mile rather than 5,280 miles in each foot. Next, we need to convert feet to inches. Feet should be in the denominator, inches should be in the numerator, and there are 12 inches in each foot. To go to centimeters, we wish to cancel the inches, so they'll go in the denominator. And we know that there are 2.54 centimeters in every inch. And then finally, to go from centimeter to meter, we put the centimeter in the denominator, and we remember that there are 100 centimeters in each meter. This means to get the result, we should multiply by 5280, multiply again by 12, and by 2.54, and divide by 100, yielding 4,828 meters, which in kilometers would be 4.8, and that's sensible compared to the distance of 3 miles because both of these are familiar units to us. The next conversion is actually related to a joke that physicists like to tell. Let's take 2 years and convert it into seconds. To do so, we recognize that to eliminate the unit year, the conversion we remember most frequently are days, in which case there are 365 of these days in 1 year. To cancel the unit day, putting it in the denominator, we know that this is related to hours in a way that we remember, such that 1 day and 24 hours are the same amount of time. Furthermore, we remember that hours are related to seconds with 3,600, so that 1 hour is 3,600 seconds. This yields the result, 63,072,000 seconds. So where's the joke? If we had done half the time interval, we would have decided that 1 year is half of this result, which is 31,536,000 seconds, which can be written or approximated as 3.15 times 10 to the 7 seconds. And so the joke is that most physicists remember how many seconds is in a year as pi times 10 to the 7. The joke is that pi is an irrational number, and clearly the number of seconds in a year has to be an integer. Get it? Well, I guess that's why physicists are not often comedians. The next one asks us to convert 12,000 cubic centimeters into the appropriate MKS unit, and cubic centimeters will become cubic meters. Now, based upon what we understand so far, we're tempted to decide that we need to eliminate the unit centimeter in favor of the unit meter, and we recognize that 100 centimeters is exactly the same amount as 1 meter. If we were to leave the calculation at this point, we would have a correct result, but simply not the desired result. At this point, the number of centimeters will cancel this one in the denominator, and one of the 3 centimeter units in the numerator, leaving centimeters squared meters. Although it would be a correct number, it's a weird unit because it's a mixture of centimeters and meters. To cancel the unit of centimeter cubed, we need to perform this operation 3 times, which means multiplying by 1 meter over 100 centimeters 3 times, which is the same thing as cubing our conversion constant. This will lead us to 0.012 cubic meters. Our last unit conversion contains all of the above in terms of its steps. We have a unit of gram centimeter per minute squared. Grams should become kilograms, centimeters meters, and minutes should be converted to seconds. We'll do each one in time. Since the gram is originally in the numerator, we need to place grams in the denominator of our conversion factor, kilograms in the numerator, And what we recognize is that 1 kilogram is the same amount as 1,000 grams. That's the first conversion. The second conversion is to eliminate centimeters. So we put the centimeter in the denominator, meter in the numerator, and we recognize that 100 centimeters is the same amount as 1 meter. 2 out of 3. Finally, to eliminate the unit minute in favor of seconds, we see that since in the original expression minutes are in the denominator, we place minutes in the numerator, divided by seconds, and we know that 1 minute is equal to 60 seconds. Those are the same amount of time. However, this is not yet complete, because what we have done with regard to minutes will eliminate one of the minute units in the denominator, but there are 2 of them because it's minutes squared. So we need to perform this last operation twice, which is the same thing as squaring it. So divide by 1,000, divide by 100, and then divide by 60 squared. To yield the answer, 1.25 times 10 to the negative 7 kilogram meter per second squared. You're probably already familiar with the expression that F is equal to ma, so that a mass times an acceleration is a unit of force. So kilogram meter per second squared we actually recognize as being newtons. So the answer is 1.25 times 10 to the minus 7 newtons.